Let's solve this calculus problem step by step. We need to prove that for a function y equals ax squared plus b over the square root of x, the expression 2x squared y 2 minus x y 1 minus 2y equals 0. First, let's rewrite our function in a more convenient form. Instead of b over square root of x, we can write this as b times x to the negative 1/2 power. This will make our differentiation easier. Now let's find y1, which is the first derivative. Using the power rule, we differentiate each term. The derivative of ax squared is 2ax, and the derivative of bx to the negative 1/2 is negative 1/2 bx to the negative 3/2. Next, we need to find y2, which is the second derivative. We differentiate y1 using the power rule again. The derivative of 2ax is 2a, and the derivative of negative 1/2 bx to the negative 3/2 is 3/4 bx to the negative 5/2. Now let's substitute these expressions into our original equation. We substitute y2, y1, and y into the expression 2x squared y2 minus x y1 minus 2y. Let's expand this expression. First term gives us 4ax squared plus 3/2 bx to the negative 1/2. The second term gives us negative 2ax squared plus 1/2 bx to the negative 1/2. And the last term gives us negative 2ax squared minus 2bx to the negative 1/2. Now let's collect like terms. For the terms with x squared, we have 4a minus 2a, which equals 0. For the terms with x to the negative 1/2, we have 3/2 b plus 1/2 b minus 2b, which also equals 0. Therefore, we have proven that for the given function y equals ax squared plus b over square root of x, the expression 2x squared y2 minus x y1 minus 2y equals 0.